All right, well, I'm Jay Norton. I'm a soil science professor and soils extension specialist at the University of Wyoming in Laramie, and that's where I am right now. I'll be hoping to talk about soil health and productivity and the idea of treating symptoms versus causes of soil degradation. And I want to link soil health to yield and talk about soil properties that contribute to nutrient water supply, and then a little bit about the idea of kind of melding the concepts of soil health and soil fertility. Okay, this I use this cartoon a lot. I'm probably risking overusing it. Says, "Give it to me straight, Doc. How long do I have to ignore your advice?" And if we think about the concept of health in general, the answer to this question is really, it depends how strong and productive you want to be and for how long. And oftentimes the medical field gets flack for treating symptoms instead of causes, and just giving us painkillers, giving us blood pressure medicine, cholesterol medicine, lowering our expectations for our performance without really talking about long-term lifestyle changes, better diet, more exercise, dealing with things that cause stress. So I don't know if you can see where I'm going with this, but if we think about soil health and productivity, that's what I thought of when I first saw this cartoon. It's like, oh, I've had this conversation before with farmers. So the answer in that scenario is, it depends how productive and resilient you want your land to be and for how long. Treating symptoms, a lot of times soil test-based recommendations just give you how much fertilizer to put on, and not, why do you need so much fertilizer? How can you improve the nutrient and water supplying properties of the soil? So since I'm first, I get to give my definition of soil health, or definitions. And it's, generally, I think everybody agrees, it can be defined as the capacity of a soil to be used productively without adversely affecting its future productivity and the ecosystem or the environment. And we really have to look at doing this and increasing productivity. Sustainable intensification is the idea that, and we're using to increase productivity to meet demands without degrading the environment or converting more land to agriculture. And soil health is a crucial part of that. It's really the integration of soil chemical, biological, and physical properties that affect both profits and the environment. And the short definition is the capacity of the soil to function. And this idea of functions is important. Whatever the goal is that we want to use the soil for, that kind of different goals rely on different functions. For example, production relies on water supplying properties, nutrient supplying and nutrient cycling, physical stability and resistance or resilience. And then these other goals, have a lot of overlap, but also rely on some other soil functions. And these soil functions are indicated by, a lot of different indicators when we talk about soil health testing. I think there'll be a lot of talk about this today. What we're going to focus on mostly today is production, but what you'll notice in these indicators for these different functions is that organic matter appears over and over, and in the ones where it doesn't appear, it's still the underpinning of aggregate stability, bulk density, water holding capacity, pH. All these things are microbial diversity. All these things are strongly supported by organic matter. So that's probably the main thing I'm going to talk about today. But oops. I want to address this idea about how the soil affect nutrient supply. Soil health, the continued capacity to function. Healthy soil has properties that supply nutrients for, and when we think of soil fertility, we're thinking about nutrient supply for optimal yield. And we get optimal yield, that also impacts soil health by returning residues, providing soil cover, a rich rhizosphere, which is important for nutrient cycling processes. Now, I want to try to link soil health and yield. And this is a paper that came out in 2019 that's pretty interesting. It's a large meta-analysis. So they looked at a lot of the data from a lot of different papers globally, mainly on corn and wheat yields. And this is a little complicated, but the gist is here that there's a sort of a critical value where more organic matter doesn't really lead to more yields, and that's about 2% organic carbon, or about 3.5% soil organic matter content in the soil. Below that, yields increase with increasing organic matter. So these lines here represent I thought I had some more information on this slide, but it disappeared. The red line is average nitrogen inputs, which I think was about 110 pounds per acre. And then zero nitrogen inputs on the lower line, and 200 pounds per acre approximately is the upper line. So nitrogen, fertilizer inputs obviously have a huge impact on yield. And this shotgun pattern reflects the fact that, there's a lot of things that impact yield. But the regression equations that these authors developed indicate the potential for soil organic matter to impact yield. For example, at 1% organic matter, yields are 20% higher than they are at that low end of about 0.2% organic matter. And this is the range of organic matter in Wyoming and in western Nebraska that we're dealing with. We don't have any croplands with approaching 3% organic matter in Wyoming. And you do have in eastern Nebraska, but I wouldn't think in western Nebraska. So this is the range we're dealing with, where yields increase with increasing organic matter, and organic matter is impacted by the type of management. In fact, in the same paper, they show that 2/3 of wheat and corn are both on lands that have less than 3% organic matter. So increasing organic matter, soil health management practices that increase organic matter are going to can have a huge impact on yield globally. Just sticking with that paper a little longer, this charts nitrogen inputs against yield, and a metric ton per hectare is equal to about 15 bushels per acre. So, and these three lines represent, low, medium, and the high end of the critical value for soil organic matter. And what this indicates is that organic matter affects or can reduce the amount of nitrogen fertilizer that's needed. And in fact, this shows that this is about maybe 70 bushels yield, and you at 3.5% organic matter with zero nitrogen, we get the same yield as less than 1% organic matter, where we had to put on 50 pounds of nitrogen to get the same yield. So, the point is that organic matter matters, and soil health management practices that improve organic matter, especially in our region, in our environment with inherently low organic matter and degraded soils, can increase yields. There's a connection. I know yields aren't the end all, but they're really something we have to think about if we're going to continue to supply a growing global population. So closer to home, just, does this, so that's the global picture. Does that apply here? Well, we've done some studies that are relevant to this. This is on irrigated sugar beet, furrow irrigated sugar beet rotations up in the Bighorn Basin around Powell, Wyoming, on-farm study. And we compared 4 different rotations, two-year rotations and a 3-year sugar beet, bean, barley rotation, and a sugar beet, alfalfa rotation. So seed alfalfa is a common crop up there. Highest yields on the one with the alfalfa in the rotation, highest organic carbon in the surface soils. The longer the rotation, the more organic carbon and the more total soil nitrogen. And so it looks like, more organic carbon or organic matter leads to higher yields. And looking at across all the data, regressing sugar beet sucrose yield against organic carbon, microbial biomass, and total soil nitrogen, we see that indeed, more organic matter, more microbial activity supports higher sugar yields. And this is against the popular notion that more organic matter is going to cause more late season mineralization and decrease sugar yields. I have a lot of farmers that strongly believe that. They don't want to increase their soil organic matter in sugar beets, but and I can show them this and they still don't believe me, but I'm working on it. Now looking at wheat in Lingle, so close by to Scottsbluff, we did a study comparing native prairie, 7-year CRP, 11 years after conversion to no-till, and then this conventional till, chemical-free, a conventional tillage field, and then a heavily tilled, chemical-free system, all right together there on this station. And you can see that in the surface soils, 7 years of no-till and 11 years of CRP increased soil organic carbon contents, and they continue to increase at these rates, which are really good. And we've done other studies that don't look quite this good, but as far as the effect of just reducing tillage on soil organic carbon, this was pretty impressive. But in this case, it didn't increase yields. I think a lot of people would say, yeah, you're going to get higher yields, especially after a few years of no-till, but we so far weren't seeing that in this case. So I'll just talk, let's see. Talk a little bit about soil properties that contribute to nutrient supply. So what's causing that? If you do see increases in yield with increases in soil organic matter, how come? Or improved soil health? Well, one thing is the cation exchange capacity, cation and anion exchange capacity. That's the properties in soil that hold and release nutrient ions. pH and alkalinity. those have strong impacts on nutrient availability. At higher pHs, we especially get constraints on phosphorus availability, iron availability. At low pH, we also get constraints on phosphorus availability, and acidity and alkalinity are definitely affected by management. In Wyoming, we have highly calcareous soils that pH goes up a bit as we lose organic matter. I think in parts of Nebraska, and I know in Montana, surface acidification is becoming a real problem, to the point where, you know, we have aluminum toxicity, and especially in no-till, where we get that stratified acidification from not over fertilization, but from long-term fertilization with ammonia-based fertilizers. Rhizosphere processes are really important. That near root environment promotes weathering of clay particles. It releases especially potassium. I think that's why we're so well supplied with potassium in Wyoming. It supports microbial communities that promote nutrient cycling and mineralization of organic matter that supply nutrients to the roots, and, you know, a lot of other processes in that rhizosphere. Soil structure, aggregation, and porosity. So these are really important for movement of water through soil and holding of water, and which obviously has a huge impact on the supply of nutrients to the roots. And then soil organic matter, both the amount and the composition. When we start to till an untilled field, the first thing we lose is this rapidly mineralizable component of the organic matter. And that's the part that decomposes every year to supply nutrients. But we speed up that decomposition and we lose that mineralizable portion rapidly. And we can also gain it back rapidly if we reduce tillage. But this also, it supplies nitrogen, phosphorus, and a lot of other nutrients through mineralization of organic material. Contributes to that cation exchange capacity. Organic matter molecules are huge, complex molecules with a lot of negative exchange sites and some positive exchange sites to hold and release nutrients. It is a strong influence on aggregation, and it serves to buffer pH changes among a lot of other, it underlies a lot of other soil health indicators as well. So when we talk, I'm almost done with my slides here already, but when we talk about soil fertility testing, recommendations often address symptoms of degraded soils without really addressing causes. So traditionally, you know, the soil testing would measure organic matter, but only to estimate the amount of nitrogen available over a growing season through mineralization. They wouldn't really say this is low, this is high. These are practices that can improve soil health and increase soil organic matter. Soil health testing is still, we're still going through, and I've worked with Bijesh on this, I think he's going to talk about it, but we're still narrowing down the best indicators, and the best indicators vary by environment, by cropping system, by soil type especially, and we're involved in a West-wide effort, right, that's just beginning to really try to sort through this and come up with the best indicators, and how those indicators can be used to base management practices on. But right now, you know, it's hard to compare one soil to another. We're not there yet, I don't think. And it's hard to interpret the results of soil health testing for management changes. I think if we could really sort of start to meld these two different approaches and philosophies, soil fertility testing and soil health testing, it's going to be a big advantage You know, I think soil fertility testing should not only give you a pounds per acre you need to apply, but should talk about alternatives to that, both immediate, you know, like what if I use manure, what if I use compost, and what type of compost, and you know, longer term soil health management changes that are going to affect nutrient supplying potential. A lot of, you know, all those soil properties that impact nutrient supplying potential that I mentioned are all impacted by management. So soil fertility testing should talk about those things. Factors like, you know, pH, structure, SOM content. Okay, well, that's my talk. And I guess I'm making a plea for more work on this and more integration of soil health and soil fertility testing, because we see that soil health does impact yield and the need for fertilizers. I think we have some time for questions.
Yeah, thank you, Jay. Anybody, please, if you have any comments, questions, put them in the chat. We have a few minutes for questions here. I think that discussion is really interesting and important to identify, right? There are scores of health indicators. So which few, 2, 3 that we really need to focus on. So as you showed, organic matter probably is the something that really comes quickly to our mind. It was intriguing to see how in that such a big data set, organic matter, when it was higher than 3, doesn't really translate into yield increase. Is there a time factor involved in that? You know, as organic matter is enhanced over time, it affects many other soil properties and might still end up helping in boosting the yield. What do you think about that, Jay?
Yeah, I think that's the case. I think what that reflects, though, is a lot of what it reflects is just, you know, the multiple factors that affect yield. There's a lot of other factors, the weather, this is all rain-fed yields that they use in this meta-analysis, but so yeah, they're variable because of rainfall, and there's just, you know, a lot of things that push variability. So but as you get down lower and lower organic matter contents, it emerges as a driving factor.
Right. I think it's very obvious that when we are sicker, medicine is most likely to work, right? Great.
That's right.
I was really amazed to see some of your sugar beet data that there was something like 7 tons per acre of sugar. That was pretty impressive. Here in Western Nebraska, I thought 5 tons per acre sounds pretty reasonable. So why are producers not convinced or not interested at this data set with that alfalfa in the rotation? They can get, that's pretty substantive growth gain in the sucrose yield. What are some of the concerns with high organic matter in sugar beet production?
You know, I think it's just been ingrained over the years that, you know, a lot of farmers believe that late season mineralization is going to provide nitrogen when they don't want nitrogen and decrease quality and sucrose yield. So I think we're making a dent in that, but, you know, it is a little bit of a hindrance to improving management practices that would increase soil organic matter.
Right. Please go ahead.
Yeah, there's some really excellent farmers that are doing, you know, barley or cover crops after barley and grazing and minimum till, but they're worried about their soil organic matter increasing too much, and they're waiting to see. I just saw a talk yesterday at the Western Nutrient Management Conference about manure on sugar beets in Idaho. And you know, and I think you've done some of that work there. Maybe Gary Hergert did. And it, you know, it's a good practice, but that also has been discouraged over the years, adding compost or manure to sugar beet yields because of the fear of that late season mineralization. But in my mind, conditions for mineralization are also ripe for immobilization. So we're not going to get a big pulse of nitrate late in the season from immobilization, because microbes will take that up just as rapidly under those good, moist, warm conditions.
Yes, I hear also same. Yeah, we Gary Hergert, who is my predecessor, he had some data set about not the manure itself, but the compost manure, and we published it together recently, and that's what we showed, that compost manure was pretty good nitrogen source even for sugar beet production. And here in the chat, there's a comment from Robin. Also, would the high organic matter provide that sustainability component for more long-term benefits and not just a yield benefit? So that's a good comment, and I think we addressed that. Yes. One more question here from Stan. But if you draw a vertical line through the peak of those curves, I assume the curve of organic matter, showing the relationship between yields and carbon, there's an evident lack of data points to the right of that line. And then combine it with the other slide showing 90% of soils having less than 3.5% organic matter. Oh, I think the number of the data points beyond 3% organic matter seems to be lower.
Yeah,
I just saying, you know, that maybe that line would continue upward if we had more data. I don't know, just pointing that out.
Right. And maybe it's hard to find soil with higher organic matter, right?
Yeah, that's what this global map shows. And this is for wheat, but the corn one looks about the same for rain-fed corn and wheat. You know, about 2/3 are grown on soils with so I think that's reflected in the data set. About 2/3 of the data is on that side of the graph. So that's a good observation, though.
Yeah. Thank you, Jay. So I'll put up one more poll